All right. Hello, everyone. This is what's new in JavaScript for fast and scalable applications. My name is Brian Turlson. I'm a program manager at Microsoft. I work on the Chakra JavaScript engine, which is the JavaScript engine that powers Microsoft Edge, as well as your Windows applications written in HTML and JavaScript. I tweet occasionally. You can follow me there. I do stuff on GitHub. You can watch that as well. And certainly feel free to email me if you have questions later about any of the content here. So today, I'm going to go over some of the new stuff that's coming to ECMAScript 6. That's the new version of JavaScript, the latest standard. It's not quite ratified yet, but it's coming. And then we'll do a deep dive into some advanced async programming patterns using these new ES6 features, namely arrow functions, promises, iterators, and generators. And then I'll switch gears and talk about some new stuff that's coming to JavaScript, some upcoming stuff that we're partnering with, or working with Mozilla and Intel to deliver. And I'll talk about that more towards the end. So ES6, ECMAScript 6, recently renamed to ECMAScript 2015. So if you're seeing ES 2015 out there, it's the same thing. It's done. It's been in progress for 6 years now, I guess, and it's finally complete. Depending on how you measure, it's perhaps the largest update to JavaScript in its history. The spec has just ballooned in size. It's just massive. And we were doing, the committee was working hard for those 6 years, so there's a lot of new stuff in it. Going forward, though, if you take a look at this little graphic here, future updates to ECMAScript are going to be much smaller. And that's because the committee is moving to a train model. So that was the rationale behind renaming ES6 to ES 2015, is that there's going to be an ES 2016 and 2017 and 2018, hopefully 2200. Out into the future. So that's super exciting. That works really nice with Edge's sort of plan, Microsoft Edge's plan to be evergreen. So what that means for you is we'll be giving you new language features much more rapidly. So ECMAScript is kind of unique. It comes with a test suite as well. It's actually a language spec with an official test suite that's owned by the standards body. And the cool thing about it is you can help. So ES6 coverage is coming. It's not all there yet. There's a lot of people that are working to get the ES6 coverage there. If that's something you're interested in helping out with, there's a lot of opportunities to dive in and learn about new ES6 stuff that way. And certainly if you find any bugs in this ES6 in any of the ES6 you see today or any of that you're trying, all of the implementers run this test suite, so it's a great way to get those bugs fixed. Incidentally, these slides, you'll notice I'm not using PowerPoint, I'm using Edge. This is written using all this ES6 stuff, so I guess you could consider my slides somewhat of a demo as well. They're a little bit fancier than slides, you'll see. So Microsoft Edge loves ES6. Chakra has been working hard on building out as much of this functionality as we can. As a result, we actually have the highest score among browsers on the ES6 compat table. You can't see the numbers, but I think we have about 81% ES6 compatibility-ish. So we've just made a ton of progress, and what that means is actually most of ES6 you can use in Microsoft Edge today. But we're not actually just sort of chasing this golden 100%. We're doing what I would term more interoperability-driven standards development. So we're actually being really careful and deliberate with implementing these new features to make sure that we don't break the web, break your code, introduce new differences between browsers that you have to worry about, and that kind of stuff. And what that might mean is in some cases we take a lot of data back to the committee and say, hey, we actually can't implement, say, array.prototype.contains because that breaks the web. And so And that was actually a real case. It breaks some older versions of mootools. So we had to, well, in that case, the fix was just to rename it to includes, and it turned out that works. But basically, we're really being deliberate here and making sure that we can give you all these nice new features without also causing you pain in other areas. And we're not just working on the current standard, the ES6 standard, we're also looking towards the future. So there's ASM.js that you can turn on in Microsoft Edge right now in about flags. SIMD is coming soon. I'll talk about those towards the end, so don't worry if that doesn't make sense yet. All right, so how many people are using any ES6 at all in your programs right now? Not too many, maybe just actually a handful. How many people are using promises, whether in jQuery or, OK, good, that's a much larger number. So ES6 plus async programming is awesome, and that's for a few reasons. Arrow functions are great. Promises are built into the language now, so you don't need a library to use promises anymore. And iterators and generators, too, combine to make some really awesome patterns. So I'll show you step by step how that works. So arrow functions are a new function syntax added to JavaScript. It's a new way to make functions. But the nice part about arrow functions is that they're super terse. There's just an arrow. I'll show you what it looks like, but it's just super, super small. It's always anonymous. It's so terse, there's actually no way to give it a name. Of course, you can assign it to a variable. But one of the most useful aspects of arrow functions is that this and arguments and super inside of that arrow function is the exact same as it is outside of the arrow function. So the arrow function doesn't change the value of this. It just uses whatever's outside. So no more aliasing this to that or self or whatever. So let's look at what that looks like. So here I have an array. And I want to sum. I want to multiply each element of this array and multiply by 2 and then sum. So let's update this to use arrow functions so I can show you just how awesome arrow functions are. We don't need that. We'll save the old code so we can compare it more directly. All right, so actually, let's start with this code so that I can just edit it on the fly. So the first thing with arrow functions, you don't need the function keyword. You get rid of it. It's too many letters. You also don't need the parens around the arguments list. If you only have one argument, you don't need the parens. If you have 0 or 2 or more, you still need it. But with just one, you don't. And now comes the only boilerplate with arrow functions, the nice equals greater than. And now for the arrow function body, if you just have one expression in your body and you don't need to, and you want to return it, you can actually just get rid of the braces and get rid of the return, and it will actually just return the value of that expression for you. So this is the exact same as this with substantially fewer characters, and it's just much easier to read. We can do the same thing here. We have 2 parameters, so we do need to keep the parens, but following the similar process, we end up with this. And if we run it, get the proper result. So with arrow functions, you spend a lot less time just writing the function keyword, for one thing, but it's also just syntactically a lot nicer to read and to maintain. So let's look at a case where you want to do something sort of asynchronous. So here we have a dog object, and we want to, the dog object can bark, but he can also bark later. And we do this via set timeout, and after this callback, we call bark on this object. So we can run this, it works fine. A second later, he barks. Smart dog. But we have this sort of underscore this nonsense, and it'd be nice to get rid of that. So let's do a similar process and clean it up. So we have 0 arguments or parameters, so we do need to have the parens there, but we can get rid of the braces. We can move this up. Okay, so at this point, this works. This works fine. But we can even go a step further and realize that because this inside of this arrow function here is the same as it is outside, this aliasing we don't even need anymore. So we can just get rid of this completely and delete the underscore, and it just works. So there's no more underscore this self-aliasing nonsense. It just plain works. So this is just super, super potent for asynchronous code where you really need this to stay the same so you can call methods on your object after some asynchronous task has completed. Arguments are the same way. So in this example, this arguments object here is going to be the arguments to this test function and not the arguments to get_args. So it's going to be 2 arguments here instead of 0 arguments. If we run it, we do see that that is the case. So arrow functions can actually have bodies. They can have blocks. That's fine. But note that when I run this guy, I get undefined. And that's because when you do use the block with the arrow function, then you do need the explicit return. It won't automatically return the last statement for you. So with that, it works. So here's an interesting case. I have a function. It's called what. And I just want to log the result of it. So I just want to see, by a show of hands, how many people think I'm going to log some kind of object right now? And how many people think I'm going to log something else, like, say, undefined or null or something crazy? The naming should give you a little bit of a clue, but it's about 50-50. So this is actually going to log undefined. And that's because these curly braces are blocks. They are not, it is not an object, even though it looks exactly like an object. This is a block with a labeled statement, and there's no return in here, so it just returns undefined. This is a gotcha. It'll get you, I promise. You can put return in there, and you can see it returns Brian. So to fix this, just know that when you're returning an object with the implicit return of the arrow function, just wrap it in parens, and it works fine. Oops. So arrow functions, really, really helpful with your asynchronous code. Async code is sort of the hallmark of async code is just tons and tons and tons of function callbacks. So arrow functions really help with that. Another big help for async code is promises. I know a lot of you are already using promises, but those that aren't, I just want to explain them briefly and hopefully demonstrate how helpful they can be for your async code. So the conceptual model of a promise is it's an object that a producer of some asynchronous value will give a consumer, and that object represents the future value. So a promise is like a single value that just hasn't been fulfilled. It's a promise for a value. So a producer, when it needs to produce some kind of asynchronous value, rather than taking a callback that it will call at some later point in time, returns a promise. And the producer is also holding some resolve and reject functions that it can use to fulfill the promise with some kind of value or reject the promise with some kind of error. And then on the consumer side, when you call an asynchronous API, you get out a promise. And then you can listen for when the producer calls this, or when the producer fulfills or rejects by using the .then and the .catch methods. The promise has 3 states. It is born into the world pending, and then once the producer decides it has a value for the promise, it will fulfill it, or maybe some error occurred and it will reject it. And once it enters fulfilled or rejected, it will never change. And that's really nice because if a promise is resolved and it's just sitting out there, you can come by later, at any point later in your program, attach a then handler, and get immediately called with the value of that promise. So let's look at some examples of using promises. So here we have this sort of producer. And this producer is going to produce a value of undefined after some amount of time. So we do that by returning a new promise. And notice that the promise constructor takes a function. It's kind of weird. It's called the revealing constructor pattern. But basically, this constructor is going to call this callback back immediately with resolve and also reject, which I'm not using in this case. So you get called back, and so we're just going to do set timeout, and we're going to resolve that promise after some number of milliseconds. So the other, on the consumer side of the promise, oh, hold on now. I don't know why Edge isn't starting up for me. Yeah, I know. This is weird. This has never happened in any of the dry runs. I was very impressed, actually. I don't know why it's not letting me actually restart it. Probably because I need to remove these hung processes. I suspect once I kill these, it will work. So let's see. Yep, excellent. Switch my zoom back. Oh, I remembered. That was nice. Okay, so remember that this is the producer up here. So on the consumer side, rather than passing a callback to this timeout, we just get a promise back, and then we use this .then method to listen for when the promise resolves. So if we run this guy, we see start, and then a second letter, we see end, because the producer resolves the promise after a second. So we can create numerous of these promises, and they all just sort of play together nicely. So let's do something real. Here we have some code, simple wrapper around XML HTTP requests get, and then we want to use it to get the top post from Reddit. So right now it's using callbacks, but let's change it to use promises. So first thing, don't need to use the callback. We can delete that. When we're a producer and we want to produce some kind of asynchronous value, the first thing that we usually want to do is return a new promise. And this gets resolve and reject functions. So it's just kind of boilerplate. They get really good at typing. Okay, so now, rather than calling this callback, which we don't have anymore, we're going to call the resolve function when we have a successful result. And we don't need to pass the error value. We just don't say anything about the error, because there was no error, and that's a really nice part about promises. Likewise, when we reject, we just say, hey, we have an error. We don't need to tell it anything about what the value is. Like in this case, I was providing null. We can just get rid of it. We don't need it. And that's all for the producer side. It's actually pretty quick to convert to promises on the producer side. So on the consumer side, rather than passing a callback, we just call the function, and we get a promise, so we can call .then on it. And here, we don't need to even worry about error handling, because then is only going to be called if there wasn't an error. And so we can just put this, our success result right in there. And then for error handling, we can use .catch, pretty straightforward. Say that log the message. And so now I've got pretty much the same exact code as I had before, but instead using promises. So we can run it. So you get the top post from Reddit. Now the cool thing about this is, like, say I wanted to get the top post from the JavaScript subreddit. Well, that failed. Well, my link is wrong. Well, clearly, I mean, I need to do that. But also, as an added advantage over the callback code, say like I got some malformed JSON back from the server and I ran it. I can actually catch that error too. So see, the error has actually popped out of this then and propagated down the chain until it found a catch. So that's one of the really, really useful aspects of promises, is that errors and values just sort of propagate down the promise chain in a very synchronous, imperative kind of way. So here's a more complex example. Same get helper as before, but this time what I want to do is I want to get the top post from the JavaScript subreddit, and then I want to get the top comment from that post. So when you're doing this with callback code, a lot of times you end up having to nest your callbacks together, and you just end up using up all kinds of horizontal indent space, and your program ends with like 50 million of these guys. I know we've all seen programs that do this. It feels like Lisp. Well, we don't. It'd be nice to avoid all of that. And promises have a really cool feature that lets you do that. And it's one of the big reasons why using promises is awesome. So this code works. Like, this code is fine. I can, inside of this outer then handler, I can create new promises and do more stuff. That's fine. But it actually works out better if we return the promise from the then handler. And what that does is it says, hey, any chained promises, any chained thens, the value that that promise resolves to, that is the value of this data parameter here, will be whatever this promise resolves to here. And so using this, you can just chain all of your operations together, and you don't need to use up any indent space or anything like that. It just more or less works. And so errors work the same way. They just propagate down the chain, so we could handle errors once here. And this will handle any errors that occur in the network request from get, any errors that occur pulling out data from the JSON, any errors that occur in the second, like all of this. All of this is handled by the single dot catch. It's just a huge, huge improvement over callback code. So as I mentioned, promises are now part of the platform. You don't need a library to take advantage of some of these really nice code improvements that you get from promises. But if you're already using a library, or you prefer to use a library because they come with a vast number of helpers and control flow tools and that kind of thing, you can do that. Actually, the built-in promises, the standard ES6 promises, will interoperate with promise libraries without issue. So you can return a jQuery promise from the then handler of a standard promise, or vice versa, and that's just going to work for you. And that's really important, because libraries actually will have their own promise dependencies, and sometimes you can end up with 3 or 4 different types of promises in your program. That'll work. That's fine. But I think one of the most awesome reasons why promises being in the platform is great is that DOM APIs are now free to return promises. So no more are DOM APIs going to be taking callbacks for asynchronous stuff. For example, WebCrypto's new API for doing cryptography stuff, that returns you promises rather than taking callbacks. Likewise, the new service worker spec, the fetch API, is kind of like a XHR request, but it returns promises rather than taking this crazy callback thing. So promises being part of the platform means if your code is using promises, you just don't hardly have to do any work. Everything just sort of plays together. And another nice reason is once things get built in, browser vendors will start to get better at tooling and performance. So expect those to improve in the future as well. All right, so the next thing I want to talk about is iterators. Iterators are a step along the way to generators, so I got to talk about iterators first. Iterators in JavaScript are conceptually the same as they are in any other language you might be useful. It's just a protocol for a consumer to pull multiple values synchronously from a producer. So JavaScript accomplishes this iteration protocol by using 3 interfaces. They're called interfaces, but actually interfaces aren't part of ES6. I've borrowed this syntax from TypeScript just to describe the shape of the interface. All an interface is to JavaScript is an object with a certain number of properties. That's basically it. So this iterable interface is the first interface that's part of this iteration protocol. And all that is a special method with the symbol.iterator name that returns an iterator. So if you want your object to be iterable, you just implement the symbol.iterator property, and it will return a new fresh iterator that you can use to keep pulling values. The thing that you use to pull values is this iterator interface. It's required to have a next method. There's also return and throw, which you can use for more advanced cases, but those are optional. All you need is a next method, and that makes you an iterator as far as JavaScript is concerned. So when you call .next, you get out a result. The way you can check whether you're done or not is that this result has a Boolean property done that tells you whether you're done or not. It also has a valued property that tells you what the current value is. And that's all there is. Those three interfaces combined produce this nice iteration protocol. There's a bunch of new language features that accept iterables now. There's the new for-of loop that you can use to iterate over any old iterable. There's a spread operator that can, for example, pass every element of an iterable to a function as individual arguments to a function. Array.from will take any iterable and convert it to an array. Obviously, be careful with infinite iterables. Like if you do array.from with Fibonacci, you'll probably run out of memory. And maps and sets constructors, like if you had an iterable of key value pairs, you could initialize a map using that. And a bunch of new language features produce iterables. So arrays, obviously they're iterable. The way that's accomplished is this array.prototype.values, which gives you an iterable for the values of a particular array. Maps, you can iterate keys, values, and entries. Entries are just key value pairs. And sets, likewise, you can iterate values. So let's look at how this works. So I have a simple example of an array, and I just want to log each item of the array. Pretty straightforward. So how does this work? Well, it'll look at this array, and the for-of loop will say, OK, I need you to be iterable. So it's going to look for a special symbol.iterator property. It's going to find it on array.prototype, and it's going to call it, and that's going to return an iterator. And then for-of is just going to call .next on that iterator until done is true, passing each value to the loop. So it's a nice, easy way to iterate. Likewise, maps. I have a simple map here with 2 entries. This default iteration scheme works the same way as array. The default iteration scheme of maps is key value pairs. But you can actually customize this by saying, for example, values. And then you just get the values of the map. But you can also do keys and just get the keys of the map. So this is a really easy way. If you have an object and you want to expose multiple iteration schemes, you can do it this way, just like maps do, and just have methods named after the iteration scheme that you want to expose. So let's actually get a better understanding of iterators by implementing one from scratch. So what I want to do here is I want to log 0 to 4. And let's sort of do this by running it and doing fixing all the errors. OK, so the first error we see is we don't have a symbol.iterator property. OK, so it's going to call counter. For-of is going to call counter of 5, and it's going to expect that the thing that this returns is an iterable. OK, so we need to return some object that has a symbol.iterator method. OK, and just for simplicity's sake, we're going to return the same object. So we don't need to do all kinds of crazy nesting. OK, so now the next error that's complaining about is the object doesn't have the property or method next. Well, that's because we are not satisfying the iterator interface. We need to implement next on this guy. All right, done. Unable to get, OK, so it's looking for done on something. And now the problem is the for-of loop has called next, but it's gotten undefined from it, and it just doesn't know what to do, so it's rightfully confused. OK, so we need to actually give it a value. So I'll implement that now. All right, and now if I run this, everything works. I'm returning iterator results from this next method, which makes me an iterator, and I have a symbol.iterator property, which returns the iterator, and that makes me an iterable. So it's a little bit complicated, but that's how you would implement an iterator from scratch. So the good news is actually you don't need to do that for the most part. You can actually just use generators. Generators, also known as generator functions, are functions that return multiple values. And they do that by being iterable and by returning iterators when they're called. So if you think about a normal function, when you call it, it's going to execute every statement of the function until it hits a return, and then that will come out of the function. With the generator function, when you call the generator, it actually doesn't run anything. It just gives you an iterator. And then when you call .next on the iterator, that's when the generator body starts running. But then rather than looking for a return statement, it's looking for a yield. And every single time it sees a yield, whatever is yielded will come out of the next, and the generator will suspend. And it'll just wait there for the consumer to call .next again. So generators fundamentally just make implementing iterators nicer. In fact, it's so nice that and useful that you probably won't, like that hand-rolling code that I had, you probably won't ever have to write that in your life, thankfully. But it turns out that this core capability that generators add to language of being able to suspend a function body until later is all you need to actually get async code to be even better than it is with promises. So let's take a look at how that works. All right, so first let's start just by understanding generators. So notice that we have this function star up here. The star is what signifies that this is a generator function and not a normal function. So we can try running it, and I am running it, you have to trust me, but there's no error. And that's because, unlike the iterator thing, generators always return an iterator. And so this is just an empty generator body. So when I call counter, and I call next on that, I get done of true immediately. So the for of loop is just saying, okay, you're done right away, so I'm not going to log anything for you. There's nothing there. So the way this works is for of, we'll get out the iterator, it'll call next, and the generator will run until there's a yield. So we could put a, could put a yield in there. And so now we get 1, yield 2, we get 1 and 2. Okay, but that's not the right way to do this. The right way to do this is so there we have the exact same semantics, more or less, as the iterator code from previously implemented in 1 line, although I think JS Hint would complain and I would make it 3 lines. But regardless, much more simple, no messing around with manually returning any of those interfaces. The generator takes care of all of it for us. So that's really nice. So now that you have kind of a little bit of an understanding of what generators can do, let's actually use it to tame asynchronous code in a really awesome way. So our timeout function is back. We're going to use that as a motivating example here. And so here's the code that we want to write. The code that we want to write is to log some value or do some synchronous task, and then we want to wait for some amount of timeout, and then we want to do some more stuff. Maybe we want to do that a couple more times, just so it's clear. All right, so you might notice that this code looks pretty close to, if you're familiar with C#, it's pretty close to what you might write inside of an async function, an async await style of programming here, except instead of yield, instead of await, it's yield. So that's kind of what I'm trying to get to here, is by yielding promises out of this generator, I want it to just wait and not run the generator, keep the generator suspended until the promise resolves, and then the generator can pick back up again. And spawn is what's going to be responsible for doing that. So let's actually implement spawn. Okay, so the first thing that we need to do is get the iterator from the generator. So recall that this doesn't run any code. This just warms up the generator and suspends it immediately before it runs any code. We need a function that's going to get the next value from the generator. And since it's asynchronous, fundamentally, it's easier if it's a function rather than trying to do it with loops. OK, so the first thing that we need to do is get the next value. Iter.next. OK, so now I've got the next value out of the generator. So whenever I do this, I need to check whether I'm done. So current is an iterator result. So first I want to check if we're done. And we'll handle that later, because that's less interesting at this point. But if we're not done, that means that this generator body, let me scroll down so you can keep looking at the generator body. That means that this generator body has yielded me something. And so it's yielded me actually a promise. So cur.value is a promise. And now I need to tell spawn somehow to tell the generator to pick back up where it left off as soon as the promise resolves. And you do that with .then. Then is how that's done. So then is going to be called when this promise that is yielded out of the generator resolves. And then I need to just tick forward again. And this will then get the next value out of the iterator, and that will continue until we're done. So at this point, if I run it, all goes according to plan, it should work. So I've successfully implemented tick, or spawn. But I'm still missing this return value for one thing. And so, well, let's just do that quick. So this return value isn't produced until after some indeterminate amount of time. Basically, it's an asynchronously produced value. And spawn, since I'm passing this generator to spawn, clearly spawn is going to have to be the one to give me this return value. And so spawn is going to be returning me some value asynchronously. So whenever that's the case, whenever it's going to produce a value asynchronously, we know we're going to need return new promise. OK, and this is going to be the promise for the return value of the generator. And the return value of the generator comes out as the value of the iteration result when it's done. So then we can just do, promise. We can just do cur.value, actually resolve cur.value. And now we've resolved this promise that I return from spawn with whatever value the generator ends with. And so we can say here instead .then got return value. And if I did everything right, we should see 1, 2, 3, and a return value of done. Oh, it didn't work. What did I do? Well, it's not obvious what I've done here. No, the return value is when I yield, you get done of false always. And when you return, that's when you get done of true, and then whatever you return from the generator, that's what's going to be the value. Oh, yeah, that's what I'm doing. I just have a string here. Thank you. Yeah, live code reviews. That's why live coding is fun. OK, now it should work. Yes, excellent. OK, thank you. So that's really cool. This is actually just the start of what you can do with this. So you can actually make yield return, or rather than give a value, well, so that's what I'm not showing here, is you could actually let v equal this value. Timeout doesn't resolve to anything, but say the timeout promise resolved to a value. Well, we could plumb that through pretty easily by saying, hey, tick takes a value, pass that into .next, that's what comes out of the yield, and then this promise is going to resolve by calling tick with that value. So, I mean, that's pretty much done. I don't have an example of that. And you can also say, hey, if a promise rejects, make yield throw an error. That's what that error and return methods on the iterator interface that I was explaining earlier, that's what you can use those for. So you could say instead of iter.next, you could say iter.throw. And then in your generator body, you can handle errors with try-catch rather than using promise callbacks. So this is just super, super, super nice to be able to use. Like I'm doing asynchronous code, but I'm not using any callbacks. I'm not using any of that stuff. It's very close to async await. In fact, it's so close that like we have almost all of the useful semantics of async await. The only thing that we need to do really is build in the spawn function and change the yield keyword to await. And actually, that's what we're going to do for the next version of JavaScript. Hopefully, async functions will be in ES 2016 or certainly soon after. And that will just be syntactic sugar for this really awesome pattern for asynchronous code. So that's generators. Generators and iterators and promises and arrow functions. These are all new ES6 features that can really help clean up your asynchronous code, can make your async code just significantly terser. It's so much easier to read. You can just do huge asynchronous chains of operations without having to worry about matching up all of your close curly, close paren things. So ES6 just makes your async code just so much nicer. So with that, I'm going to take a step away from the ES6 stuff and talk about some of the progress in Microsoft Edge in some new future stuff that's coming to JavaScript. It's not in ES6, but these are more forward-looking things. So the first one that I want to talk about is Asm.js. Asm.js is a optimizable, low-level subset of JavaScript. So let's unpack that and think about what that means. We have a subset, so that means that Asm.js code is just valid JavaScript code. If your browser doesn't know what Asm.js is and it comes across Asm code, it'll run it just fine because it's actually just JavaScript. It's just not going to optimize it, so it's going to run it really slowly. But the inverse is actually not true. Most JavaScript code, in fact 99.999% of JavaScript code, is not valid Asm.js code. It's a very, very, very tiny subset. And as a result, this Asm.js stuff is not something that you're going to be handwriting. I mean, maybe some of you will, but I wouldn't recommend it. It's very difficult. It serves more as a target for compilers. So there are actually compilers out there right now. Mscripton is one of them. That will compile your C or C++ native code to this Asm.js subset, and that will run in the browser at near native performance. So how does that work? Well, Asm.js code is compiled ahead of time. There's no JIT, there's no bailouts, there's no GC. So that gets you really predictable, solid performance. It's very much like your native code where you compile it once and then the machine just runs it. There's no runtime getting in the way. Likewise, because this subset is so tiny and geared towards making optimizations possible, we can do some really, really aggressive optimizations, similar to the kinds of things that native compilers are doing. And this gets us performance wins, especially in compiled to JS scenarios. And this gets us actually really close to native performance. So with that, I want to show a quick demo of what you can do with Asm.js. Oh, it's got to load. But I'll switch so we can watch it load together. So Prime World Defenders is a game. It's written using the Unity engine. And much of this code is actually native code. And it's been compiled to run on the web using Asm.js. So here we have, it's using WebGL, and it's using Asm.js, and it's running at super close to native speeds. I'm going to play a little bit of this. I mean, it's tower defense. It's kind of dangerous. Make sure you warn me if I'm up here for more than a few minutes. but anyway, I mean, you can see it's really nice and smooth. You get really nice graphics, and the performance is great. It's really awesome. So we've partnered with, or been working with, Mozilla on ASM.js. Mozilla pioneered this technology, and we were happy to bring this to Microsoft Edge. You can actually turn it on right now if you have the latest bits. If you go to About Flags, if you scroll all the way down to the bottom, there's an Enable ASM.js flag. And this Prime World Defenders is out there. You can find it, you can play it. There's a bunch of other ASM.js plus WebGL stuff. And it's a lot of fun. So enjoy that. But anyway, so ASM.js is really, really awesome technology for getting us for allowing native code just to run directly onto the web. But there is some problems. So if you think about your native code has access to the hardware. It has access to the CPU instructions. You can drop into assembly even if you need to and get super low level. The web platform doesn't have that capability. It has JavaScript. And so the only access to hardware that you get is sort of mediated by the web platform. And a really key technology that is lacking in the web platform is SIMD. SIMD stands for single instruction, multiple data. And these are hardware instructions that do multiple calculations, but just use a single instruction. So the way to think about this is, say you have 4 numbers and 4 other numbers, and you want to add each pair of numbers together. You could do that with 4 add operations, but it'd be nice if we didn't need to use 4 operations. It'd be nice if we could use just 1 operation to do all those adds together. And that's actually what SIMD does. With 1 SIMD operation, you can add 4 numbers to 4 other numbers and get a vector of the results. So this works on anything where you need to apply the same operation to all elements of a vector. This, for example, might be RGB or RGBA pixels. So if you're doing image manipulation kind of stuff, multimedia, that's a great opportunity for SIMD usually. XYZ or XYZW coordinates, another example of something that can be easily translated to SIMD. Or even just arbitrary length arrays where you can just take chunks of 4 off of this array and process them in chunks. You basically get a 4x speedup. So Intel, we've been working with Intel to build SIMD into Chakra and into Microsoft Edge. It's not available yet, but it will be soon. So this machine here is actually an experimental, or a Edge build, I guess experimental build. And I do have SIMD enabled on it, so I can actually demonstrate what SIMD can do for us. Well, it's okay. Sorry, I accidentally closed it. Oh no, my network is down. Okay, give me a sec. It'll be worth it, I promise. Actually, we don't need Prime World Defenders opening anymore, do we? It'd be better if it didn't. Demo Wi-Fi. No, don't find it. Okay. This doesn't seem right, does it? Well, this is what happens when you're running even experimental OS. There it goes. All right, so SIMD, here we are. Okay, so this is a Mandelbrot illustration. This is a fractal, and we can render this guy without using SIMD. You notice we get, I don't know, it's kind of jerky. It's not quite as smooth as we'd like, especially when we get into the more detailed parts of the fractal. Drops down to maybe 9, maybe 8 frames per second. So let's turn on SIMD. This is the exact same hardware, but actually taking full advantage of the CPU. This is not parallelized across multiple cores even. This is just using SIMD instructions. And now the animation is really nice and smooth, and it's using this, basically the same amount of CPU power. So that means you get 4x FPS improvement in some cases using the same amount of power from your device. It means better battery life. And you can actually compile your native code that might be using SIMD optimizations to run on the web platform now. So that's SIMD. So we're super excited to show you SIMD. It's not quite in yet, but it will be soon. So I hope after all of this, your takeaway is that the future of JavaScript development is here. With ES6, there's some really great new stuff that you can do. Async programming especially benefits from ES6 with promises being built in. You don't need a library anymore. Arrow functions, typing function keyword all the time, that's all gone. Iterators and generators, new capabilities in the language that not only make asynchronous code nicer, but make other things nicer as well, like actually iterating things. And Edge has just great support for this ES6 stuff. Right now, you can try it out. And certainly after you do, let us know what you think. You can contact me on Twitter, especially. And we've also brought some near-native performance to the web platform with SIMD and with Asm.js. You can compile your native code to run on Chakra in Microsoft Edge at near-native speeds. So with that, I'm here for questions. I'll also be hanging out at the Insider Lounge after this for probably an hour, hour and a half. So have at it. Any questions? Sure. Sure. So the question is, I glossed over it because I didn't, it's kind of a hard thing to talk about, but I do have extra time, so I will do it. So the question was, what is that weird square bracket thing? And I assume you're talking about, on the iterator's code sample, I had this, let's see. Right, I had this, this thing, right? This is your question, what is this nonsense? So this is a computed property, so I can actually put, inside of here, this is a property name, so I could put foo plus bar, and this would make a property named foobar. So it's called computed properties. That's inside of the square bracket. And the symbol thing is a new thing. Symbols are a new kind of property that doesn't have a string name. It's actually just a, it's kind of like symbols in Ruby, if you know Ruby. It's like a unique name. Every new symbol is guaranteed to be unique. So like I could make a new symbol like this. And then there's this symbol global that has a bunch of built-in symbols. And these are what the language knows to look for certain protocols, like the iteration protocol is built around the symbol.iterator. And there's also a symbol.toString tag, which the language will look for to see what the toString output of an object should be, for example. So that's a new ES6 feature called symbols. That's what this is. No, because, I mean, you could, so you might say, like, well, symbol. You could make a property call with a string, but then the for of loop isn't going to see this thing as iterable. It's not going to satisfy the iterable construct. So you do need to use the global symbol.iterator property, because that's what, because this for of loop is basically going to say, you know, if obj symbol.iterator, then it's iterable, else, you know, throw some not iterable error or something. So that symbol.iterator property key is what the for of loop and everything else that accepts iterables is looking for on your objects. But the good news is you don't really need to implement that. Just use generators. Other questions? Yes?
How do you foresee people who are maintaining existing websites out there, like expecting to run like mainnet?
Mm-hmm.
How do you foresee developers kind of migrating to ES?
So the question was, for people that are supporting older browsers today, how are they going to migrate over to ES6? How are they going to start taking advantage of this stuff? So I think actually one of the most exciting parts about being a JavaScript developer right now is that unlike in previous eras when we got new versions of the language, now there's this new thing called transpiling. It's basically compiling one version of JavaScript to another version of JavaScript. TypeScript does this, so you could use a bunch of ES6 features in TypeScript, and that will compile that code down to run on ES5 or even ES3s, so that would run all the way back to IE9, maybe even earlier. There's also other tools out in the wild that do this. Babel is a really popular one that targets, rather than the TypeScript language, it targets quite strictly ES-Next, ES6, and some ES7 stuff. And that will compile your generators and all your other symbols and all that stuff down to just ES5 code. So that's a great way to get started, because then you can just check in ES6 into your code base, and then as part of your build process, you just dump out this ES5 code, and that goes up to production. So it's actually a really exciting time. Unlike previously where we had to wait for all of your customers to have the latest browser, today you don't have to do that. You can just use these transpilation tools. Sure. What?
What are your slides in that you do all this?
I wrote it myself. Much of it is using ES6 stuff. The editor is the Monaco editor. I believe it's the same that is on visualstudio.com and also in code, I believe. The joys of being a Microsoft employee is I can just roam around and grab code for places. Yes?
Is the SIMD stuff going to be exclusive to Edge, or is that going to be part of the ECMAScript standard?
For now, that is only, I mean, it will be delivered in Edge before it hits the standard, but the intention is certainly for it to be part of the standard. Intel is championing that proposal in the ECMA TC39 committee, and that may land in ES7 even, so you might get that in ES 2016. No, you can use SIMD outside of ASM.js, although I believe in our upcoming implementation of SIMD, they will be tied together. You only get the performance benefits of SIMD in ASM code. But the intention is eventually that SIMD will be available even outside of ASM. So you can, it's just like you get this global SIMD, and then you can call operations on SIMD to create vectors and to do these mathematical operations in parallel.
Is there auto-vectorization of loops or anything like that?
No auto-vectorization. There was a separate proposal that actually Intel was working on with Mozilla called Parallel.js, but it turns out auto-vectorization is really, really hard. Like in JavaScript, knowing what functions are pure, what functions don't have side effects is actually a really difficult problem for the compiler, and auto-vectorization depends really heavily on being able to do that kind of stuff. Anything else? Yes?
So if you're targeting non-Intel-based, browsers, browsers from a non-Intel chip,
Yep.
what's the best way to, like in your example, you had a button that says use SIMD or not use SIMD.
Mm-hmm.
So is your JavaScript code going to need to have an understanding of the process architecture?
No. So the question was, if I want to use SIMD, do my clients need to be using Intel processors? And the answer is no. SIMD is available fairly broadly. I think it's called Neon on ARM. But the goal of the SIMD proposal that's getting added to the language is to actually target the sort of most common types. So for example, while SIMD on some architectures might even have 512-bit vectors, that's not going to be part of the web platform. The web platform is only going to have the really common, probably float32x4 and int32x4 vectors to make sure that if developers use it, they're likely going to be able to take advantage of that optimization on their clients machines. And I imagine if you're running the SIMD code on an architecture that doesn't support SIMD, then the JIT is just going to emit slow code and actually do the simple thing of adding each one individually rather than relying on SIMD. So the developer won't have to query to see whether SIMD is supported before using it. Other questions? Did I get all of them? All right. Well, thanks everyone. Thanks a lot for coming. Hopefully you learned a lot. I'll be around, so definitely just walk up to me and ask me questions. I'm happy to talk about this stuff.